Hi everyone, welcome to this video on number sequences. So we've got just a definition here. Number sequence is an ordered list of numbers defined by a rule, and the numbers in a sequence are called the terms of the sequence. So let's leap straight into an example. Here we have a sequence. It goes 3, 7, 11, 15, 19, and so on. And so we've seen these kinds of patterns before. We can see that it starts at 3 and it's increasing by 4 each time. So it describes the sequence in words. That's all we're going to say. Starts at 3, increases by 4. Excellent. State the values of T2 and T7. So this is the terminology we use. This means the second term. So T2 is going to be 7. T7 is going to be the 7th term. Now if I look here, I've got 1, 2, 3, 4. I've only got the first 5 terms. So that means I'm going to need to push this a little bit further. So the 6th term, we're just going to take 19 and add 4 to that. That's going to be 23. And the 7th term will be 27. So we've got T2 is 7 and T7 is 27. The 7th term is 27. Okay, find an explicit formula connecting the sequences and hence find T25. So an explicit formula needs to be in the form Tn. Now, what we should notice is if we have T1, T1 is 3, T2 is 7, T3 is 11. Okay, we can see it's increasing by 4 each time. We've already noticed that. Okay, but we want to come up with a rule for the nth term. Now what we're going to need to do is find out, well, what is T0? What is the 0th term of this sequence? And so what did we add 4 to get 3? And the answer is -1. -1 plus 4 will give you 3. So now we can come up with the rule. We've got the nth term, Tn, okay, so it could be for any term, is equal to -1 plus 4n. So notice this, -1 plus 4 times n. So if we want to find the first term when n is 1, -1 plus 4 is 3. If we want to find the second term, so -1 plus 4 times 2, so that's going to be -1 plus 8, 7. -1 plus 12, 11. So this rule here can generate any term for us. Then it asks us to find T25. So that means we're going to use n is 25 to find the 25th term in this sequence. So we could extrapolate all this the way out. You know, I've only gone up to 7 and it would take us quite a long amount of time to reach the 25th term, or we can use the rule that we've generated here. So we're going to have -1 plus 4 times 25 because n is 25. So that's going to be -1 plus 100, which is 99. The 25th term is 99. Okay, so that's the first way we can define a sequence, is what's called an explicit formula. Then we're going to look at a recursive formula, which is a little bit different and a little bit more challenging. So what we're going to notice here, we've got T1 is 3, and then we've got T2 is equal to T1 plus 4, okay, which is 7, isn't it? It's 3 plus 4, which is 7. And we've got T3 is equal to T2 plus 4, and T4 is equal to T3 plus 4. So it's a recursive formula. What it's doing is it's saying, take the previous term and add 4. That's how you generate the next term. T2 is T1 plus 4. The third term is equal to the second term plus 4. The fourth term is equal to the third term plus 4. And so then our rule, the way we're going to write that in as a recursive statement is like this. T of n plus 1 is equal to T of n plus 4. So if we have the nth term, then the next term, T of n plus 1, is going to be equal to the nth term plus 4. Okay? So for instance, if we want to find the 13th term, it's going to be equal to the 12th term plus 4. If we want to find the 150th term, it's going to be equal to the 149th term plus 4. So that's a recursive definition there. Okay, then let's look at an application of a recursive formula. We've got this formula here. T1 equals 3, and T of n plus 1 is equal to Tn take away 2. Find the first 4 terms of the sequence. So let's write our answers over here. It wants us to find T1, T2, T3, and T4. And they've given us T1. T1 is 3. We're going to need that. We're going to need to apply that. So then we need to find T2. Now what I want you to notice is T2 is equal to T of 1 plus 1. Okay, because 1 plus 1 is 2. And then look up here. If we've got T of 1 plus 1, if that means our n value is 1, that means it's equal to T1 take away 2. And we're told T1, the first term is 3. So we've got equals 3 take away 2. And 3 take away 2 is 1. So we've got the value for the second term. All right, so the sequence is going 3 and then 1. Okay, we need to find the third term. So then we're just applying the recursive formula. We've got T3 is equal to T2 plus 1, isn't it? And we know we've expressed it as T of 2 plus 1. That means in this circumstance, n is 2. And so we're going to have that's equal to the second term take away 2. And we saw before the second term is 1. And we're taking away 2. 1 take away 2. Now we're going to have minus 1. All right, let's move along. T4 is going to be T3, T of 3 plus 1, which is equal to T3 take 2. Now here, these are subscripts, okay? So what I'm saying is the fourth term is equal to the term that is the third plus the first term. And we've got T3 take 2. And we know from previously that the third term is minus 1. We're taking away 2, and that's going to give us minus 3. Okay, and you may notice a pattern there. You can see it's going down by 2 each time, and that's listed here. Okay, but I'm just trying to clearly explain that recursive process. So this sequence here, 3, 1, minus 3, and so on. But how does a recursive formula work? Is that it uses the previous term to dictate what the following and subsequent term is going to be. So that's a bit of an introduction to number sequences. It does start reasonably easy, and hopefully the rest of it's okay.